Good day, everyone. So, today we shall be diving into an interesting topic titled Simple Electrical Wiring. We shall be understanding the circuit, the tools, and the accessories for safe electrical installation. So, let's dive into this. First thing we look at is the electric circuit itself. An electric circuit is a complete path through which electrons or current flows. The part is made up of cable or wire which connect all the components of the circuit. And part of this electric circuit are the power source. Power source is the one that provides the electrical energy. An example of such is the battery or the generator we use now out. Another component of the electric circuit is the conductor. The conductor are the cables or the wires that we use in transmitting this electrical current. Okay, they are made up of what? They are made up of copper most times. And another component again is called the load. The load are the appliances we use at home, like the lamp, the TV, the fan, the laptop, and so on and so forth. Then the fourth component is known as the control. The control simply are the switches and the fuse to turn current either on or off. These are the four major components of an electric circuit that make it work effectively. There is a law that governs the flow of electric current, and that law is called Ohm's law. It's a law that shows a mathematical relationship between electrical voltage, current, and resistance. That is, V equals to IR. The law actually states that the electric current flowing through a circuit or flowing through a metallic conductor is directly proportional to the potential difference across it, provided temperature and other physical conditions are kept constant. So here is an example. We have to calculate, here we have a current of 0.5 ampere flowing in a circuit with resistance 60 ohms, and we have to calculate the potential difference. The potential difference is represented with the letter V. The electric current is represented with letter I, and the resistance is represented with letter R. So in this question, we are giving our letter I, the current to be 0.5 ampere. We are giving our resistance, capital R, to be 60 ohms. And then we have to find the potential difference, which is our V. So using the Ohm's law, which is V equals to IR, we multiply I by R, and that is 0.5 multiplied by 60, and that will give us 30 volts. That is how to calculate the voltage or potential difference using Ohm's law. This formula can also help us in determining electric current. We are given potential difference and resistance. And it can also help us to determine resistance if you are given potential difference and electric current. All you need to do is to make the unknown the subject of the formula. So we have some wiring tools and materials that we use in electrical circuit. These wiring tools are hand tools used in the process of electrical installations. Okay, and they include black saw tape, clips, wooden block, cable, screws, and many more. One of the least among the one mentioned, we have the plier. The pliers is used in holding, in coating, in joining conductors or cable. Usually it is coated with rubber material. Another good tool is known as the hammer. Of course, with hammer is used to drive nails inside the wall to hold wiring accessories such as wooden block and clips. And then we have the screwdriver. The screwdrivers are used also in holding lamp holder. They are used in spooling nails actually, and this nail that's called a screw. So this screw help in holding a lamp holder. Okay. Sometimes we use this screwdriver as tester if they are designed that way to determine the presence of current flowing through the circuit. And we have different types of screwdriver. We have the star screwdriver, we have the flat screwdriver, and we have the ratchet. So what are the essential wiring materials aside from the one we have mentioned? We have the small knives and punches. These are used for joining. The, the rubbers are used for joining. The punches are used in making holes in the wall. Alright, and we have the cutters as well. The cutters are used to cut wires where necessary during installation and repair work. Of course, we have the hand glove. The hand glove is used to protect the hand from electric shock and other hazards. And we have the black sew tapes. This is used to cover exposed conductors to prevent electrical hazard also. We have the metal clips and screw. These are used to hold cables firm on walls. Screws are used to fasten lamp holder and other accessories like we mentioned earlier. Then what are the wiring accessories? You see, the wiring accessories and the wiring materials are different. Now the wiring accessories are known as accessories that are not used for lighting. They can be used for that, but they are not used in lighting fitting. We refer to them as wiring accessories. Okay, so any device other than luminaries associated with wiring and current with lighting appliances. So when we do not use this material for illumination for lighting fittings, then we call them wiring accessories. Okay, and these accessories are rated for maximum voltage and current they can withstand without overheating or failure. One of them is called the switch. Okay, so the switch of course does not give light, but can be used to turn off light or turn off or turn on light. So it doesn't allow current to flow and also allow current to flow. It's used for switching on and switching off current. So we have it as tumbler switches, we have ceiling switches for controlling circuits. Another wiring accessory is called the lamp holder. The lamp holder is used for holding lamps or bulb. Okay, they come in different design. We have the ceiling roses, we have the joint boxes for mounting lighting features. Another wiring accessory is called the socket outlet. These are plugs, adapters, connectors for connection of powers. And then we have the protection and the last one. These are fuse boxes for circuit protection against overload. Then we go straight to the consumer equipment and safety. We that use the electrical current, we are the consumer. We use it in charging our phone and watching TV and so on and so forth. There is need for us to make use of equipment that we not cause hazard. So this equipment are into two. We have the main component. This main component equipment include the gear, the switch gear, the fuse box, and the consumer unit. So we connect all accessories through this main component, okay, to prevent hazard. So another component that is for the consumer is not at the earth protection. In this case, all socket outlets are connected to the earth terminals to prevent earth leakage. Okay, because if you don't earth your appliances, they can cause electrocution. So the earth protection aspect help in preventing earth leakage by connecting all the terminals to it. Okay, so wiring circuits. In simple electric wiring, there are majorly two types of circuits, and these are called the series circuit and the parallel circuit. For series circuit, the components in series circuit are connected end to end in single part. While for parallel circuit, the second type of circuit, the components are connected across multiple parts. So while series is in single end to end part, parallel are connected across multiple parts. Okay. For standard practice, all house wiring connect light point in parallel So our light are actually connected in parallel. And the essence of this is that when you connect light in parallel, you can easily turn off one and the other one is not affected. But there are special cases like ceremonial lighting, photo studio, and darkroom which may use series circuits for increased brightness. So there are cases where you can connect your light also in series so that when you turn off one light, the other one goes off. But in a residential environment, generally when you connect bulb, they are connected in parallel so that when you turn off bulb A, it does not affect bulb B, which we all observe in our various homes. Alright, so what are the process of circuit connection? Because you need to follow the process for you to connect correctly. Number one, you have to start with the fuse box. When you are connecting circuit, the connection must start with the fuse box. So circuit begin at the fuse way in fuse box or splitter unit. So connection starts from the fuse box, then all the way you connect your wire to the switch. So having run through your wire in the fuse box, then you run it through the switch. Wire runs from fuse box to switch control point, and from there you take it to the lamp holder. Okay, so from the switch, connection goes to the what? To the lamp holder, and then from the lamp holder it returns to the neutral. Neutral usually is in black color. Okay, so that is how you connect circuits. That's the process of connecting circuit. Start at the fuse box, connect to the switch, connect to lamp holder, and back to the neutral. Okay, multiple core cable, what we refer to as the twin or tray core insulated and shield. There are cables that inside of there you can find two cables, you can find three cables. We call them multiple core cables, and we use on surface wiring in joint box. Okay, and single insulated core cables are used in conduit. When we say conduit, they are wires that we don't see with our physical eye. They are inside the blocks or the wall. We can never see them because they have been inserted inside the wall. So that's where we make use of the insulated core cables. All right. Now let's see another practice question here. Here it said a current of 0.8 ampere flows in a circuit with resistance 80 ohms. Calculate the potential difference within the circuit. Okay, so using our Ohm's law again, which is V equal to IR, in the question, we are given current, which is 0.8 ampere, and we are given resistance, which is 80 ohms. So we have to find V, that is the potential difference. So our solution will be V equals to IR, meaning that we are multiplying I by R. So 0.8 times 80, and that will give us 64 volts. So this is where we are going to be doing our cutting on the lesson today. Hope you have learned something on simple electrical wiring. So until I come your way again, thank you for watching and have a wonderful day. Bye now.